This section presents considerations for storing raw and processed data in an analytics pipeline. The Data Characteristics section introduced the concept of a modern data architecture with data lake storage at its center, surrounded by other data stores focused on specific workloads. As the diagram suggests, this architecture must allow for data movement in and out of the lake and between other storage components. The goal of this architecture is to make all the data available while controlling access and moving data efficiently to perform analysis. Let's look at this architecture in the context of the AWS services you can use to build it. A collection of AWS services centered around Amazon S3 work together to provide data lake functionality. AWS Lake Formation provides management of the data lake. AWS Glue provides the data catalog, and Amazon Athena provides a SQL query engine for analyzing data directly from the lake. This diagram shows the AWS services that provide additional storage in this architecture. The student guide for this section describes the role of each data store, and the scenario section of the well-architected framework Data Analytics Lens provides additional details. An important call-out is the combination of Amazon S3 for the data lake and Amazon Redshift for the data warehouse. These services provide a powerful integrated storage approach to serve a variety of analytics needs. As an architect, you should be able to generalize when to use a data warehouse and when to use a data lake. For data warehouses, think highly structured, curated data for complex queries and business analytics that are worth a higher cost of storage. For data lakes, think unstructured, raw data available for exploration at a lower cost. Let's take a closer look at the factors that drive your pipeline storage choices. You're always going to be balancing performance and cost. How quickly do you need this, and what's the cost to get it faster compared to the business value? Amazon S3 has a lower cost of storage than Amazon Redshift. Depending on the access pattern and how you organize your data in S3, you might get the performance you need without moving data into a data warehouse. For example, if you need to query logs by date, storing each day's logs in its own folder can improve the efficiency of that query, and maybe that's enough. But if you're looking for efficient querying over very large data sets spanning long periods of time, the higher cost of data warehouse storage might be worth it. Amazon Redshift Spectrum might give you the best of both worlds. You can use Redshift Spectrum to efficiently query S3 buckets without moving the data to Amazon Redshift, and the cost is less than storing data in the warehouse. Another factor in selecting pipeline storage, data retention. How long and at what cost do you need to store data? For example, when can you archive data from a higher cost storage option to a lower one like Amazon S3? And then within Amazon S3, when can you move data to different storage classes to further reduce costs over time? And of course, the data itself drives your storage choices across the pipeline. For example, you might be capturing business data from a relational database or real-time data collected in a stream. Then you might transform the data and store it in the data warehouse or the data lake for analytics use cases. The main point is to select storage that optimizes cost and business value, recognizing that data pipelines use a combination of storage types, and the data will use different types of storage as it moves through the pipeline. Remember, the major components of the AWS data architecture include an Amazon S3 data lake and an Amazon Redshift data warehouse.